Okay, let's go ahead and get started. This is Dan Kahn, Executive Director of CNCF. I want to thank everybody for joining the call from around the world. I happen to be in San Francisco today, but hopefully the connection is good as I'm going into the office here at 8:05 a.m. I wanted to give a heads up on some work that I've been doing and trying to get some feedback on that I'm hoping is going to flow in well to some of the other discussions that are taking place here. And this is a proposal for what we're calling the CNF Conformance Test Suite. And so the idea is to create a new open source project that would pull together a set of tests and test suites from different upstream projects and would work both on functional tests on the artifacts of CNFs, but then also functional tests of the CNFs running in order to be able to show that the CNFs are following best practices. And so I've been working with the Volk team and a few others on this, and I'm hoping to be able to circulate a deck in the next few days, which needless to say, should generate a ton of interest and feedback and given the intensity in this community, probably a lot of criticism. But I wanted to give folks a heads up that that is coming and is something that we're actively pursuing. I think it's going to particularly flow into this next conversation that Robbie is going to kick off around RA2, where I'm very hopeful that this test suite, if we're able to develop an initial version of it relatively quickly, could be a very useful input into that RA2 process, and could be a way of trying to represent some of those best practices. But there's a huge amount of open questions. And then I guess my final comment would just be that if the test suite is successful and we're able to get some interest and traction and such, the goal would be to have it accepted into CNCF as a sandbox project, and that it would have maintainers and an update schedule just like any other open source project. But I would point out that although I'm executive director, I don't actually get to control what projects become CNCF hosted projects. We have this independent technical oversight committee, kind of like our Supreme Court, and they're the ones that decide. And the answer, if they looked at a slide deck, is always going to be no. They'll evaluate actual code. And then, as with everything in the telecom world, I think feedback from the operators is going to be hugely impactful. So I think I'll stop there. I could take maybe 5 minutes of questions, but it's probably just worth waiting to see the slides. I'll be sharing them via Slack and the mailing list, and so would love to get your feedback on them. But it doesn't make sense for me to read, to spend too much time on it now when I'd rather have you see the full presentation with the context and then comment on that. But I guess I would maybe stop there. Taylor, is there any sort of critical piece that you think I left out there in terms of an intro?
No, I think it's good for an intro. I'm definitely interested in hearing feedback on the overall, the high level, as well as when it gets into categories and certification levels, what people are thinking.
Great. Okay, would anyone else like to comment?
Probably
Please.
a question, Don, if you don't mind. So I know there's some activities happening in LFN around OVP phase 2. I'm just wondering how that relates to what you described here around the CNF conformance test. Do you imagine that conformance test will be focusing more about how cloud native an application is, whereas LFN OVP phase 2 look at interfaces, APIs, and infrastructure point of view, or how do you see the split, or is there any relation between these two projects?
Robbie, I think you should look over these slides and we should do a call about it at the end of the week. I honestly, I mean, the one thing that I'm certain of is that I have no interest in CNCF kicking off a competitive effort to CNTT and RA2. So I absolutely am focused on cooperating. I remain a little bit unclear on which is upstream, how decisions get made, the kind of fault lines between specs and implementation, and those kinds of details.
All right, thank you.
Okay, well, so I think I'll stop there. Hopefully that's enough of a teaser that will get you to at least open up the email when I send it out. I would maybe ask Taylor or Lucina to just mention the upcoming events, and then we could hand it off to Robbie, I think, as the to talk about RA2 in the meeting in Prague, and then next steps there.
Sure. So unfortunately, thanks. Yeah, my laptop actually screen just froze. Lucina, would you mind?
Sure. Yeah, we have some upcoming events. The schedule for KubeCon, Cloud Native Con in Europe, which will be held in Amsterdam the last few days of March and first few days of April. The schedule has been announced, and on Tuesday the 31st in the afternoon, there will be a CNF testbed session going over creating a cloud native user plane for an evolved packet core. And on Thursday, there will be a birds of a feather for this Telecom user group. In April, there'll be the Open Networking and Edge Summit North America. CFPs closed today, and the schedule will be announced on March 5th. KubeCon China, the CFPs are open for July, and those close on the 21st of February. Then in September, we'll have Open Networking and Edge Summit Europe. The CFPs are open for that as well and close June 7th. And then later on in the year, we've got KubeCon in Boston in November, and the CFPs are scheduled to open up in April for that event. Are there any other events of note that you'd like to add to the agenda?
That CFP list there at the top, the idea is to make sure specific talks that are relevant to the group are noted, since there's so many things going on. So if there's something that someone is presenting, whether you're doing it or you think someone else's talk is very relevant to the conversation, then please add it to that list.
Great, thanks for that, Lucina and Taylor. So shall we give the floor to Robbie?
Yes, thank you, Don. Thanks, Taylor. So we do have in the call as well, I believe, Tom and George Guns and Cedric, who are actually leading a lot of the RA2 and RI2 proposals. So, but before that, we discussed deeply into thinking about what should we do in RI2. Let me show one slide that will explain what's the thinking in CNTT and why we're really interested in doing the RI2 discussion. And just to clarify that the slide we're going to show now is all about the Openstack Vision, and this is not the Kubernetes and container-based infrastructure. What we really want to is having the exact same picture we have in front of us, but to apply to containers and Kubernetes workload. So this is what we do have today in the Openstack world, which is talking about VNFs, not CNFs, and we'd like to have a similar story to address the CNFs and Kubernetes and containerized workload. So in CNTT...
Robbie, I'm sorry, but I'm not seeing your slide. I'm not sure, maybe others are?
Can you guys see the slide? Anyone?
No, I can't, unfortunately.
No, I can open it.
All right, let me try again.
I think you can take control, though, and screen share.
I did the control, yeah, and I'm doing share. Let's see.
Here it comes.
All right.
Yeah, now we got it. Thank you. Please go ahead.
That's good.
All right, perfect. So this is, as I said, this is, if you look, it's an Openstack. So we do have a reference model in CNTT, and that reference model just explaining how the infrastructure should expose the resources to upper layer. And then we do have two reference architecture. The first one is called the reference architecture one, which is based in Openstack. And this is explaining how do you design and architect your infrastructure based on Openstack technologies. And once we do have the Openstack, we do have the reference implementation, and this is really the RI1 in this scenario. And this is really looking at how do I build an infrastructure based on the reference architecture using the open source technologies and open source components available out there. And we're working with OPNFV. This is why you see OPNFV in here, which is we're using the community installers available in OpenFV to consume the artifacts we generate in the reference implementation and create an installation or an implementation of the infrastructure using the community lab available in OpenFV. And this is really what we refer to as the reference implementation, which is really the realization of the reference architecture and building the infrastructure from open source component using open source installers and open source projects, and using also community labs to install the infrastructure. And as you notice here, part of the reference implementation is a document, it's a specification document that will give you the target state, which is really specifying in details what are the artifacts that we'd like to deploy and what are the metadata and the values of the different configuration the infrastructure need to have. But also we do have some requirements when it comes to what requirements from networking, what install requirements when we need to support in order to be able to install the infrastructure. We do have also lab requirements specifying the minimum and maximum of some of the configuration from platform perspective, CPU, for example, RAM and sockets and NIC cards and so on. These are the requirements when it comes to a lab. But also finally, we have the Cookbook, which is saying in details what instruction you need to perform in order to allow you as a consumer for the infrastructure to install the infrastructure, whether in a community lab or in your own lab or in a lab as a service environment. Now, once the infrastructure is installed, then we do also work with OPNFV to leverage their existing tooling and ecosystem to do testing and conformance to the infrastructure against the CNTT specifications. So we do have the RC, and the C stands for conformance. So the reference conformance one in CNTT looks at what are the test cases we need to allow me to test the infrastructure based on requirement and specification set by CNTT. So if CNTT specify a particular protocol, for example, I just want to make sure that this infrastructure can actually support that protocol. If the CNTT says that I need to have the huge page enabled, for example, then there should be a test case here to test if a huge page is enabled in the infrastructure. And this is really, as you can see, there are two parts of this. There's the NFVI testing, and there is the VNF testing. When it comes to NFVI, it's all about is the infrastructure capable of exposing the resources I am promising to my application based on the reference model specification existing CNTT. When it comes to the VNF testing, once the infrastructure is validated and it's conformant to CNTT specification, you get actually a badge for that from LFN. And this is why you have the LFN OpenFV verified badge for your infrastructure. Once the infrastructure is ready to be used, we put a VNF on top of that. We need also to be able to test if the VNF is conformant to the CNTT. In essence, does it use the same interfaces, the same API towards the infrastructure to consume those resources from the infrastructure in the way the CNTT is expecting. And this is where we write test cases in CNTT to specify what are those testing we need to do for VNFs to make sure they are compliant to CNTT. And the idea really here, which is still under development, once the VNF is running on top of the infrastructure conformant to CNTT interfaces and APIs, you get a badge as well that will make sure that will certify that your VNF is actually can run against CNTT compliant infrastructure. But also we're thinking about some performance testing. So, and this is a little bit tricky. So this is still in the roadmap. And this is really looking at how do we characterize the workload into different categories to allow us to test the performance for that group of VNFs and figure out how they measure and score against the reference implementation for the golden VNF we also would like to have in CNTT. Now, I guess the question is, what I'm trying to understand, when it comes to Kubernetes and containers workload, we do have a reference architecture 2, and this is really specifying the cloud platform in container-based and using Kubernetes technologies. And this is really where we specify what components we would like to see. We specify the networking details. We specify the lifecycle management of the infrastructure as well as the workload. And the question becomes, if I'm a CNF developer and I would like to say, okay, I want to build my application using, I want to build my CNF against the infrastructure that CNTT is approving of. So what is the infrastructure? Where does it exist? How can I actually have an instantiation of the infrastructure using open source components and open source elements and tooling to allow me to actually install it in my lab and run CNF on top of that and maybe do some testing around this. Now, this is where the request and ask from in my initial email about, we need to start thinking about what is the reference implementation is, what does it live, and what tool and existing open source components and tooling we would like to leverage and take advantage of to build the reference implementation. Once we finish that, in my view, and once we have the reference implementation being able to be instantiated, we need to think about, okay, how am I going to test that? And then we need to think about opening the RC tool, which is based on targeting the Kubernetes-based platforms and being able to test any Kubernetes-based platform and to check if they are conformant to CNTT specification. And finally, going back to Don's initial point around the CNF testing, also would like to understand what kind of testing we would like to do in terms of CNF to make sure that CNF is conformant to CNTT. For example, if we specify in CNTT that the interface to the infrastructure has to be based on MEMF interface, just an example, then if the CNF is not using MEM interface, then it's not considered conformant to CNTT. And hence we'd like to make sure that any CNF built and designed is using the same interface, the same open API towards the infrastructure, which CNTT is approving of. And hence the need to have that kind of ecosystem around testing and certification is really important to make sure the CNTT story is complete end to end. Any questions? Okay, so one of the things we also, to kick this off, one of the things we start to look at is we start having an issue in GitHub, and I'm gonna show it in the screen. And this is literally saying we need to really figure out how do we do this reference implementation based on the reference architecture specification. We do have an Etherpad, as you can see in the GitHub issue. And I guess the question I would like to ask the community here, what are the existing thinking around the project exists within CNCF or the open source in general that will allow us, CNTT, to be able to use those open source projects to instantiate that reference implementation to have something conformant to CNTT or RA2, the Kubernetes-based one. Hello?
We can still hear you.
Yeah. Is there anything else you'd like to add, Tom, George, Cedric, from CNTT side?
I think the only thing I'd add, so Tom Kivlin here, sorry, is it's very much an iterative approach. So I think it's everyone agrees that RA2 is not in a position where we can test an implementation against it in a complete and robust way. But we want to get started on understanding what the constraints are of the implementation or the requirements we have or any feedback that there might be into RA2 based on actually implementing something. So that's why we're starting RA2 before RA2 is kind of complete or near complete.
Yeah, so this is Sukhdev from Juniper. So the bigger question I would ask the CNCF TUG community is that, is everybody familiar with RA2? what is happening in RA2? Have they had an opportunity to look at it? So perhaps that could be the starting point. So share that, take a look at it. Whether how does it map to the CNCF tug work which we are doing, and what are the commonalities, what are the differences, and we take that. So that's and RA2 is driven from the resource model, RM, so which is fairly defined. So we take that, and then we want to take it to the RI, which is the implementation, which is what Rabi is talking about. So I think that this is the best way to connect all the dots and get to a joint collaboration effort among both communities. Does it make sense?
Yep, makes sense to me.
Yeah, so this is Frederick. So I've started to take a look at some of the reference architecture and the specs attached to it, and so I've been submitting pull requests as I go through it to try to get things so that they're a little bit easier to work with in the cloud native space. The thing that I'd like to try to flag for you all is to when you're writing out the specs, the best way I can describe Kubernetes versus previous stacks and technologies that we've seen is that Kubernetes itself is an emergent system, an emergent platform, where you put the thing that you want, and then the system attempts to converge to it, as opposed to having the top central controller push down details to all of the things underneath of it and trying to centralize all that logic into one place. And so be cognizant of that as you write the specs out, because it has some. It sounds like a detail, but it has some interesting properties that greatly affect how you build things. The second thing as well is on the wording, and it's the same advice I gave to the container networking working group when they first started, is aim to try to get the capability that you want in the spec, because I noticed there's certain things that are implementation details that are leaking into the spec itself. And so instead of saying in the spec, multiple interfaces should be injected in by this particular technique, just put the thing out saying that the system must be capable of having multiple interfaces injected into a kernel. And then if you want to list down those particular techniques, then you can create a subspec or something similar that links back to that original definition. So in order to implement this thing, these are the recommended paths or so on for making that happen. But what it means is that if a new platform comes around, or Kubernetes itself changes, that we don't have to, that the specs are not baked in with implementation assumptions, and that it gives us a migration path from one to the other, and is something that allows people to come in and enter into the space. And it does add a little bit of work onto the CNF testing side, because we have to make sure that those CNFs will continue to work, whether you pull them in using one technique versus another. But what that will force us to do is come up with really good interfaces in order to make sure that that cooperation works, and we'll end up in a much better place in the long run.
Yes, I think Frederick, we completely agree with your comments. Now, one of the things that we need to be clear on is the current RA2, and we understand it's not mature technology yet to assume that we can have a complete implementation based on the RA2 today. And you bring a good point, where this is one of the reasons why we would like to have that kind of complete feedback loop or life cycle to allow us to actually get some learning we witness in the implementation back to the architecture and vice versa. And although in CNTT we always say that we need to be as restricted as possible to the actual implementation. In some scenarios, when it makes sense to be very specific, I think we should be not shy to specify things as we feel there is a need to do that. Now, there's this compromise line, a sweet spot we need to find. Where do we need to specify more and where we need to be completely abstracted? Now, to really better understand that and the impact of this, we'd like to have the reference implementation started to appear, so we can actually start experiment with it and feedback all the learning back to the RA2. Now, there has been some comments in GitHub I saw around we should mature RA2 first before thinking about doing the RI. Now, although I do understand the rationale behind this, one thing we believe the RI will allow us to think about this problem now, will allow us to identify those projects that we need to put more resources into and more focus into. Now, similar to talk about OpenStack technologies, we have OpenAV, we have Airship. We know we have put some resources in there and some focus in there. I would like to do similar things in here where we say, okay, we do have different projects scattered around the CNCF, and we would like to rally around a few of them and make sure we do have some attention going towards those to be the ones that we use for installing the infrastructure and being able to get that learning back. Now, any details in the RA or RI, I'm sure there's a lot of discussion going to happen around which way we should go and which technology we need to use and do we need to specify an implementation or not. But I think if we at least trying to figure out what are the tooling available today that will allow us to have that instantiation of the infrastructure, so we could think about how the ecosystem would look like end to end. Now, I know there are some comments here around things like OKD, Cube 1, Cabascree, Metal 3. So, and there's Testbed, for example, right? So I do think, at least my opinion, that when things are out Testbed, this is where the reference conformance is more relevant to this. When we talk about reference implementation, maybe one of those tooling can be used alongside some of the labs available to install the infrastructure. I'd like to understand from your point of view, Frederick, and others, what would be the right tooling to start with in terms of being able to instantiate the infrastructure?
So I think we can break the infrastructure down into multiple parts, because one of them is how do you instantiate the actual container infrastructure itself? Like how do you instantiate Kubernetes, and versus how do you install a variety of components that your CNF will need, then versus how do you install the CNF itself. And so rather than driving into implementation details right now, my recommendation would be to point us at where we can help discuss these type of things. And I think the approach you're taking is right. Like, let's put something down on paper. Let's go build something in order to see it work. And then let's come back and discuss what we've built, and then changes as we go on. Now, one thing that was really interesting, and this is what the SIG networking group did, the Kubernetes networking group, is when they were developing their specs, they actually allowed people to come up with competing ideas, implementations, and specs, and would even implement them in some scenarios at the same time in parallel, and then they'd come back with all of their learnings. And so I know that this stuff may be too large to do that for the whole solution, but for the smaller components, we certainly can do that for some of them as well. And also, but even just getting like the multiple ideas and specs down, even just thinking through those, because we now have a better understanding. We've been around long enough that we can get a better understanding of how some things will work and run thought experiments against them. But yeah, I think you're heading in the right direction with that. But I would definitely recommend like getting a place where we can discuss like what are the solutions that we currently see in heavy use within the enterprise space. And my recommendation, you don't have to follow this, but my strong recommendation would be to try adopting those tools first. Like if you're working in cloud environment, adopt things like Terraform. If you want to install infrastructure, use things like Helm. or operators, or a mixture of the two of them, and that way that we can see whether those meet your needs, and if they do, then it's easy. We can just slot them in, and you get the benefit of the community working on them, as opposed to something that is only worked on. Let me rephrase. The benefit of the wider community, of the whole cloud native community working on them, as opposed to just the telecom community.
Absolutely, and this is one of the reasons why actually we came to the CNCF testbed, is trying to get the opinion from the community here. Now, you mentioned you're proposing to have a meeting to discuss that. I mean, I was thinking maybe we can use the CNCF TUG meeting, which is this one, to kind of try to go into the details and see which tooling is more appropriate to install Kubernetes. So you mentioned here, in my view, a key point. So how to install Kubernetes, and this is a question I would like to maybe start finding answers for. Now, installers, right? I guess this is what it goes to. So my question to the community: do we consider OKD as an installer, Cube One, Kibis 3, Metal 3? Is that the choice? We need to pick one of those. And you mentioned Helm chart. So we have Helm, this feeding into a tool, right? And the result will be a platform installed in a lab. So which lab is that? What's the tooling is this? Which tool we're gonna use? And are we saying we're gonna use Helm as the way to describe the infrastructure to install Kubernetes? Is that something we can get alignment for?
Yeah, so before we even jump this far, like what I would recommend doing is start literally just like put a Google Doc in this channel. I can create one right now, and have people put suggestions down for all of them, because we can also shop it around and say, hey, what do you use to install, and try to get a more complete list. And so before even jumping into the details, like I would recommend just like, let's get a survey of what's out there first. And if Dan and others are okay with spending some time on here, I'd be happy to do that as well. But I think the once a month cadence is probably not fast enough for what you're looking for. But we can definitely do a lot of this async, and at least start getting those initial questions done. Because right now, what the concern is that we have some tools that are being described, but it would be good to get a survey of the larger set of tools that are out there, so we can start looking at the capabilities of all of them. Like I don't think we understand the problem well enough to say this is the tool that you have to use.
So I might push back a little bit on that, Frederick, which is, even if we did that survey and had perfect information, I don't know that we're ever going to want to say, oh, you must use KubeSpray to install your Kubernetes in order for it to be CNTT RA2 compliant. I mean, that we have this whole certified Kubernetes program where the basic premise of it is that you should be able to modify the software and modify the installer and come up with your own installer and install it however you want to. And then once it's installed, that we validate that it is conformant and acts the way a Kubernetes cluster should. And so I guess I'm a little unclear why we would want to restrict the number of allowed installers at all.
I apologize. I came off poorly on that. They have a reference architecture that they're building, and so the recommendation would be not to say you must use this, but for them just to get something off the ground in their implementation.
Yes.
This is purely about the reference implementation, and I think one of the characteristics that's fairly important here is, for instance, the size of the community activity and so on, so that we pick a tool that is fairly common, I guess. And that would just be the reference implementation that CNTT uses to validate CNFs against. On the commercial side, you can basically pick any tool you want, and that needs to be differentiated.
Yeah,
okay, I hadn't understood that. Sorry. So I mean, if that's what you're looking for, then I certainly would recommend the CNF testbed, which uses KubeSpray and is generally a relatively vanilla installation of it. and you know, KubeSpray is part of the Kubernetes project and makes use of kubeadm, which is the official recommended set of tools for installing. But I would just be hesitant on saying, oh, that's the correct way of installing it, or particularly the only way. I guess I would have a semi-related question for Robbie in particular, which is your document talked about what test centers could be used to validate it. And I guess I did want to check in on that, whether you have reviewed the way that certified Kubernetes works, where we don't require or allow the use of third-party test centers. One of the maybe semi-novel aspects of our approach is that it's an open source test suite. The vendor runs it and uploads the logs showing their performance. But then one of the key ideas is that they're rather than just needing to take the word, just the community just need to take the vendor's word for it, any user of that platform is able to come back later and rerun that test suite and show that they're still getting valid results. And so in that sense, we're crowdsourcing the validation or you know, lack of cheating by participants rather than having essentially a paid contractual relationship. And so I guess I just wanted to check in, are you aware of that model, and is there a reason? I mean, I understand that that's not the model that OVP uses, but do you feel like it, and so for RA1, I definitely understand that's the direction you're going to be going, but for RA2, that there might be an openness in CNTT to trying a different approach toward conformance and certification?
Sure. So for RA1, even for RA1, we don't say you have to go to a specific lab to get certified. We do support, as I mentioned, the self-certification, meaning the all open source components, open source tools. You run the test, you create the log file of the result of your testing, you submit the result into the portal, which is Dovetail and OpenMV. We have the CVC community look at the logs, and we require 2 pluses from the community. And once we have that and we agree that the results are genuine, then we give the badge for that particular vendor. Now, we do also have the third-party lab scheme, which is not more than some companies that have some experience in helping vendors running those certification, but they don't certify on behalf of CNTT anybody. The certification happening is the same way as if you run it in your own lab. And I guess the community lab is just a free lab that anyone can access and experiment with the infrastructure. The intention of behind that is not to be the only route to get certification. Now for the RI2, the expectation is to have something similar, more open, to your point, where anybody can install the tools required, specified by CNTT. And once you install the tooling, the test cases, run them, the requirements, required test cases to run, you submit your results in some way or another into, I know we haven't talked about OVP phase 2 yet, but the intention is to have something similar to that, some group of people reviewing those results and deciding based on that if that platform is conformant to CNTT or not. I don't know exactly how the Kubernetes do conformance tests for Kubernetes platform today, but this is something we certainly can learn from. If their model is better than the one we're thinking about, we certainly are flexible to adopt that one instead.
Hi, this is Mark Shostak. I've got a question for the TUG, which is kind of an extension of that from Robbie and also something Frederick said earlier, which is what is the strategy that you guys are employing or plan to employ in areas where there are multiple choices for technology? CNI comes to mind, first, right? How do you plan to certify or qualify a CNF without any determinism in which type of CNI it's going to use? Is your test bed going to support all of the CNIs, or what's your vision there?
I'll take that one, Mark, but I would definitely emphasize that this is one of the most challenging aspects to it. So from a testbed standpoint, it absolutely can support any CNI, because just in the process of booting up a cluster, you could install the CNI and then the CNF. You could install the CNI plugin that you want to use, and it could be open or closed source, or have all kinds of configuration and such. But I think the underlying issue is maybe the most challenging aspect of this, where I think we're all agreed on the goal here is that a operator like AT&T can buy your CNF infrastructure from one vendor and then get multiple CNFs from different vendors and have them all interoperate if they're all conformant. That's the promised land we're trying to head toward. But if each CNF that you purchase, the vendor says, vendor Acme says, oh, here's our amazing firewall CNF, and it only works if you install Acme CNI on this cluster. And by the way, if you install Acme CNI, then you can install Huawei CNI or Ericsson's or anybody else's. Then all we've done is recreated a single vendor walled garden. So I'm very cognizant of. In fact, I have a slide here that I'll be sharing in a few days called the Cni Trap. And one possible way out of it is to try and define the characteristics of a CNI that a given CNF needs. But I don't mean to imply that it's a simple problem or has necessarily a simple solution.
You didn't think I was going to give you an easy question, did you? But yeah, so and again, that's just an example question. Really what I'm looking for, and I'll look in that material that you said will be forthcoming, is what the approach is, not just for CNI, but in general for areas where there are multiple options. So you just can't, wire, you can't wire your test bed one way or demand everyone uses one paradigm. So I'll just leave it at that and an exercise for follow-up.
And this is one of the example, Dan, when we said within CNTT, we'd like to be as abstracted as possible. So to your point is, what are the features that the CNF would like to require from a CNI plugin? If we can abstract that, we would do. But if scenarios where we find ourselves, we have to go into the details and start specifying more, we will go as far as it takes to make sure the CNFs can run together in the same infrastructure without having to dictate any requirements underneath. So that's really the approach we're taking in CNTT. Okay, so I think, I don't know, what's the agenda for today? I don't want to steal the whole time of the meeting, but it will be good to understand what do you guys feel the next step. So I heard about a survey, I heard about a cube spray being the tool used by CNF testbed, and I heard about having a dedicated meeting around that. So what's the feeling? Are CNCF Tag Group in this call happy to spend the time of this meeting to discuss that particular topic, or would you prefer us to have different meetings to talk about that particular subject in particular?
Are there any other topics? We only have 11 minutes, by the way.
Okay. All right, so may I ask, so we did have a question here, right? Which is Helm is the format we're going to use, a tool, which tool we're going to use? I know some people mentioned the QSpray, the lab, what the lab would be. I know we have, there was a demo in Red Hat, the one that shown in KubeCon in San Diego, and that potentially could be the starting point. If we're starting to think about how they did it and what tools they used, maybe that's where we can start from. But what I would say, I encourage everybody to go to this page. It's in the minute of the meeting. Add your thinking and thoughts around that, and then if everybody votes for a tool or think about the tooling that will be the most ones to start using first, that would be a great, and then we can agree on the lab and what format we need to have that. And maybe if the community is happy with it, we can continue discussion next week or the week next meeting, the CNCF Tag group. But the more input we have beforehand, the better we prepared to have that discussion and have some decisions, hopefully, around which one to start with.
Robbie, can I just add something to that?
Sure, of course.
So I think for me, the more important thing that we need to get at the moment is well, there's two things. So one is where we can deploy a Kubernetes platform. So the lab location, packet.net, whatever. So what do people know is available for us to start using imminently? Because I think that's important. The second thing is the installer. So whether it's OKD, Kubespray, whatever, what do people have the skills in using? Because I think as a community, we don't want to go and choose something that no one knows how to use. So I think that's what I thought Frederick was getting at, is kind of understand what the community knows how to use already. Because the bit about Helm and installing the CNFs for me is not really what we're after at the moment. That's a secondary part about managing the workloads within Kubernetes rather than managing the platform itself.
Yeah.
Yeah, the two recommendations that I have in this area is, number one, so Taylor Carpenter had put it really well. Separate these things out into stages. And I need a Kubernetes cluster. How do I install it? Versus second stage would be like, how do I install the components my infrastructure needs? And another stage maybe, how do you install the CNFs and so on? So break them up into logical stages, and that'll give you a starting point. We already have a Kubernetes cluster. Okay, what do I need to add in? And the second thing is, there's a whole effort that's already done a lot of work towards this. That's also ran by Taylor Carpenter and his colleagues, where it's called you're familiar with the CNF testbed, and the CNF testbed is designed to be a repeatable lab that you can spin up, and it spins things up like Kubernetes. As Dan Rex said, it uses kubeflow and which uses kubeadmin underneath, which is the closest thing to an official Kubernetes installer. It's the recommended path, and just start with the tooling from there, and that'll actually prevent you from repeating a bunch of work. You'll have something that's repeatable, that works in with the rest of the community.
Maybe one more thing to consider is also, and maybe the CNF testbed guys can elaborate on that a little bit more, CI/CD integration. So it's, from my perspective, maybe that's step two. Well, certainly that's step two after step one. But at the end of the day, we probably want to regularly run the test suite against the reference implementation to validate that the tests are suitable and that the platform still passes and all those things. So that's just also a generic question that needs to be discussed, where that should be hosted and what that look like, at least from my perspective.
That is another big strength of the CNF testbed, is that because it's open source and continually updated, we would encourage any vendor that wanted to incorporate it into their own internal development to do so. And so, and then it's also very feasible if, for example, if there's open source CNFs that are reference CNFs, that we can set that up with an ongoing CI process.
Does that, maybe that's a stupid new question, but in the CNCF context, does it run already in a CI/CD fashion? I have to admit, I'm wearing an OpenAV hat right now because that's where I've come from, but like OpenAV has CI/CD tooling to deploy stuff and then run tests and so on. Does similar setup exist in the open on the CNCF side as well for the testbed and or others that we could hook into? I mean,
yeah. So we could set it up. I wouldn't say it's set up that way today. I think the key question around CI is integration of what? Are you saying as each new version of Kubernetes is released? are we checking that it still installs and runs correctly, or each new version of a CNF? There's something that we have to be evaluating against to have a CI/CD system.
Absolutely. So I was more focusing towards like a CI/CD pipeline to validate that the reference implementation as we build it and envision it can correctly be deployed every day, and whatever we add new features, does it still pass the compliance or conformance test suite that we will be talking about? These things, right?
No,
just bring it up.
It's a fair question. So there's the Sonobui testing system that's used by certified Kubernetes to run the test suite, the conformance test suite on top of Kubernetes. And essentially, we're not doing that today in the CNF testbed just because it would be duplicating a ton of work that's happening upstream. But it is something that we'd be very happy to build in if it seems like that would be valuable.
Okay.
All right, so
this is Taylor. Right now, we do have as some CI efforts around deploying Kubernetes and a specific use case or set of use cases that we're running. And like Dan says, it's really the CI/CD pipeline should be focused on whatever you want to validate. And so there was some specific things that we wanted to keep verifying. I think going back to what Frederick said, though, knowing what you're wanting capabilities-wise and what's driving it would be a good place to start. So if you have those stages and you say, we want to be able to deploy to whatever the lab location, and we want anyone to be able to deploy that, and then going with what Mark was saying as far as people will want different options you may have different CNIs and other things. So do you want to provide those? You're probably not going to say, we're going to implement all of them. But if you can say, here's the capabilities, you can plug in different CNIs, then you can start looking at the tooling that provides that. So CubeSpray allows you to specify different CNIs. I'm sure you can do that with different ones like CubeOne and other things. But if you have those laid out, the capabilities and requirements, then the tooling, the tools can fit into that. I think it'll make a little bit more sense. And that ties back to I think some of the original concerns of this is more of a proof of concept of saying here's an example of a platform, and anyone can refer back to the reference architecture, which should be those capabilities. And then another platform can be implemented by anyone, and ideally test and CNS that are deployed to that platform will work on this reference implementation in the same way that they work on someone else's platform.
okay, so you're saying we need to spend some time on the requirements?
Yeah, I would say requirements and what you would like for people to be able to do. It looks like in the chat, at least Tom is, and there's been some responses. I've been asking some things, but if you want to be able to deploy to wherever that location is. So if it was something like Packet or there's a public lab, that's fine. And you want to be able to deploy to your own labs, well, those are requirements that I think will drive some of the tooling. And then you can look at stuff like, do you need lifecycle management of a cluster right now? Whatever things you're wanting, that may or may not be necessary for something for this reference implementation. But if you have that, then that'll help drive conversations about the tools.
Okay, makes sense.
A really important one that I want to bring up is the underlying hardware infrastructure and configuration. If I would at least have that noted, it's often skipped that someone set up the underlying hardware, any type of network configuration, VLANs, everything else, and then the software is installed on top of that. And I think that's important to at least note. If that's expected, okay, and probably at least document the expected configuration to run the tool, run the software to bring up a cluster. And then otherwise, is there a desire to be able to automatically do that for a lab and testing? Do you want to be able to configure the network dynamically?
Yeah, that's a good point, actually. Okay. All right, I think how many I don't have much time, but I think we have a good plan now. We're gonna spend some time on the requirements, and maybe in the next CNCF group we can have a quick look at that, and then once we finalize the requirement, understand was it needed, we can think about the tooling and the physical location and the pipelines afterwards.
Okay,
Yeah,
I'd like to thank everyone for the call today. We should stop there, but definitely look forward to continuing this on Slack and email and on the RA2 GitHub issues. So thank you for participating.
Thanks, everyone.
Goodbye.
Bye.
Thank you guys.
Cheers.
Thanks. Bye-bye.